Alright, on this video we're going to take a look at the XFEM and how to use that. We won't go into the details of the theory that is available in the Abaqus manual. I'm using Abaqus version 6.14, and for those of you that have seen my integrity videos, I'm trying a little bit different recording software that should highlight where my mouse cursor is at. Alright, so the first thing I did is I've loaded up Abaqus, got it started. I'm going to create a part. 2D planar deformable shell and approximate size 500. And I'm going to key in some points. So I'm going to go over here and select the Create Point button. And like we had for our plate previously, I'm just going to go 100, 0, 100, 100, 100, minus 100, minus 100, 0, minus 100, 100, minus 100, minus 100. Let's see where we're at. Going to resize the screen. And then I'm going to do a couple additional points. Let's see, I don't see one down here yet. So let me go make sure I got minus 100, minus 100. Okay, there it is. And I'm going to do a couple of additional points. I'm going to do 100, 90, 100, minus 90, and on the other side minus 100, 75, and minus 100, minus 75, and that's going to help me with my partitioning just a little bit. Alright, in fact that might be a little bit steep, but we'll take a look at the issue and we'll fix it if we need to. Alright, so the next thing I'm going to do is I'm going to go through and I'm going to connect these up with lines. I'm going to go around this mesh counterclockwise. Alright, and then I'm going to go done. I'm going to go into my property module. I'm going to create a material 1, that's fine. Mechanical, elasticity, elastic. I'm going to use the Newton and millimeter system, 210,000 megapascals for Young's modulus and 0.3 for the Poisson's ratio. And then I'm going to go into damage for traction separation loss. I'm going to go maximum principal stress. Maximum principal stress of 100 megapascals, and for my sub option I'm going to do crack growth, so I want a damage evolution, and I'm going to have displacement at failure, and I'm going to put 0.1. The defaults are fine. I'm not going through and describing all these different kind of options, but like I said, you can look at the manual for that. Alright, I got my material created. Now I'm going to create a section based on material 1, and then I'm going to assign the section. I'm going to select that part and hit done and OK. Now I'm going to continue down. I'm going to go into the assembly. I am going to instance the part into the assembly. We may need to change this to be independent, but we'll find out soon enough. And then we'll go into the step. We'll create a step. Static general. I'm going to put a time period of 10. And for my incrementation, because crack growth can take a lot of increments, I'm going to change this to 1,000. And we'll see if that is a problem or not. If we need to do more, we can do more. Alright. Going to the interactions, we need to partition this mesh. So I'm going to go Tools, Partition, Face. I'm going to select that face, and I'm going to use the shortest path between 2 points. Now it says dependent part instances cannot be edited or assigned mesh attributes So I'm going to go back and I'm going to make it this part independent from the model tree. So I'm going to go into my assembly. I'm going to right click on that part and I'm going to select make independent. Okay, now I'm going to go back, and now I'm in my interaction still. I'm going to go back to tools, partition, the face, use the shortest path between 2 points, and let's choose this leftmost point over here and this right point over there and create a partition. And we're going to do it again. I'm going to double click back on that. I'm going to partition this face by going between this point and this one over on the right. And I'm going to create another partition. Now the reason why I want to create a partition like this is because I want to isolate my boundary conditions from the place where I want the crack to grow. Those boundary conditions can cause elevated stresses locally, particularly if you're over constraining a little bit, and we will be over constraining for my purposes just to show this method. And so I don't want the crack to grow down at the boundary conditions. It's just not going to look very interesting for us. So what I'm getting set up to do is I'm going to specify this big region in here that's kind of a trapezoid shape as the region in which the crack can grow. Alright, so I have my interaction. Now I'm going to go up here to Special, Crack, Create, and I'm going to select XFEM. You can change the name of the crack if you want, and then Continue. Now I'm going to select changes to geometric faces. I'm going to select this trapezoid shape right here and select Done. Alright, if we want, we can select a crack location. I'm going to select None. We'll see where this crack pops up. And there's some other options you can specify if you want. We're going to allow crack growth. That option is grayed out, but we're going to see this crack grow. We're going to hit OK. Let's go down to the next one. We're going to put our loads on it. I'm going to create a load. We're going to do a pressure. And I'm going to select the top edge. And I'm going to put a pressure of -100 so that it'll be tensile. Okay, I'm going to create another load, a pressure load, and hit continue. And I'm going to select this edge over here and this edge over here. Now I'm pressing shift on my keyboard and I'm selecting that, so I got this 2 lines selected right here. I'm going to select Done, and I'm going to put on a magnitude of -50. Now the reason why I'm doing this is if we only had a pressure along the top edge of 100 and our failure criterion is 100, we're going to see a bunch of cracks just all over the place. So I want to skew this crack a little bit by putting some load over here so I get a bending load on this plate, and we're probably going to see the crack show up down on the lower left hand corner of my region. We need some boundary conditions. Oops. This one right here, boundary conditions, and we're going to do symmetry to anti-symmetry and cast, and I'm just going to select the bottom edge. If it doesn't highlight for you immediately, just kind of hover the mouse over it, and Done. And just to make this easy, like I said, I'm going to kind of over constrain it. I'm just going to select and cast. Now since we're doing a 2-dimensional planar shell, some of these are not applicable, but that's okay. We'll zero out all the displacements and rotations along the bottom edge. Alright, we did the load. Now we need to do the mesh. We need to seed the mesh. I'm going to seed it with a size of 5. And then we're going to mesh it. And I think this mesh will work for us. You see it has some awkward looking elements. But these are in the zones that are not part of the XFEM zone, and I think this will still work for us. If it doesn't, then we'll fix it. What I have noticed is if this region is meshed with these kind of weird looking elements up here, the XFEM procedure will not work. So you have to go back and get a fairly nice looking mesh in your region. Alright, let's see what we need to do next. I think we're ready to create a job. And I'm going to call this job 11. Source is model 1. And hit OK. Now it's not submitted yet. I'm going to go down here, right click, and hit submit, and we'll see what happens. Should go through the preprocessor. Running. The preprocessor has completed successfully, so that's good. The actual job is running. And if we don't run out of increments, or we don't have too much, it should work out. Okay, so it said it completed successfully. Sometimes you will see, if you don't have enough increments specified, remember where I changed that 100 to 1000, it will bail out on you and stop. So you have to go back and try again. All right, now I'm going to go up here to File, Open, Output Database, and I said job 11, so I'm going to select that. Okay. Oh, there's one thing that we forgot to do. I'll need to go back and we'll need to request the output to display the crack. So I need to go back and do that and rerun the job. All right, so I'm going to go back here to the model. I'm going to go into field output requests. I'm going to create a new one. You can add it to the existing one, but it's just as easy to create a new one. I'm going to go down here to failure and fracture, and I'm going to select Phi LSM and Psi LSM. For a 2D, you don't need both of them, but in general for 3D, you need to output both of those. All right, all the other defaults are fine. Now I'm going to go back here and submit this again. It's going to ask me about overriding, and that's fine. So let's try this again. I knew as soon as I hit that submit button that I needed to go back and figure out what those to add that output. And those two output requests are essential in being able to see the crack form and propagate. So we shouldn't have any problem with this one. Okay, it just completed. I'm going to open the file up now. Okay, that looks a little bit better. You see down at the bottom you have the crack. I turn on the contours, and I'm going to animate this. All right, and you see, let me slow this down a little bit. You'll see the crack form. It actually forms in the interior just a little bit, propagates out to the left edge, and then it starts propagating, and it hits the boundary, kind of arcs, and it hits the boundary, and that's where we start to get to our mode 1 opening and the typical stress field pattern, that kidney bean shape, if you will, that we see from our prior stress analyses. So that's an example of using XFEM. Again, I haven't gone into the details of how it works in the implementation, but this will give you an idea of how to get it set up in a model. One last thing we'll do, let's stop this. Let's see what happens if we change our load on the right edge. Instead of being minus 50, let's change it to 75, but pointing to the left. Let's create a new job. Job 12. And I'm going to submit it. And it shouldn't be any problem. It's running. Preprocessor has completed. Just a few more moments here. And then now that job's complete. So let's go and open up the ODB file for job 12. Turn on the stress contours and take a look. Our crack has shifted to a new location because we're pushing on the right side. We're getting a tensile stress down at the bottom on the right edge instead of on the left edge. So the crack's initiating and it's hitting that boundary again, and it's continuing to load up and show our typical stress distribution. All right, so for homework, what I'm going to do is I'm going to ask you to go through and either use this as the basis for an example where you do XFEM and give me the results, or you can do something else. Now, XFEM can be used in both two-dimensional and three-dimensional structures. For this one, it's just a lot easier for me to illustrate this on our typical plate.